morning! There was a bit of a little technical hiccup there. I don't know why, but Open Broadcast Studio likes to crash when I switch from that wallpaper to me on camera talking to you. So I'm hoping that everything is working. I'm kind of keeping an eye on things here, looking at the chat. I am here out of the black hole, which is me trying to simulate a Rubik's Cube in processing. I have been thinking about this. Do you know about these images of the black hole? Really astounding, really amazing, beautiful stuff. I hope that maybe I could do some type of video or coding challenge or simulation about it. I didn't get a chance to kind of watch the live stream, although I hear it's kind of wrapping up just about right now. So everybody welcome from just seeing the first images of a black hole to watching a completely inept, awkward person on the internet try to program a Rubik's Cube in processing. Hi. All right, people are saying hello to me. I see Simon is typing, so I'm going to assume that I am here talking to you live on the internet. This is the Coding Train. My name is Daniel Schiffman. Thank you to the sponsor of the Coding Train live streams, Brilliant.org. If you go to Brilliant.org/codingtrain, you can sign up to find lots of courses and puzzles and practice problems around all sorts of topics from computer science, mathematics, and various things. I will come back and look at today's daily challenge from Brilliant.org a little later in the live stream and see if we can solve it live on air. Do a light ray simulation. That's a good idea. So if you have, I guess I'm going to be lagging behind. If I could really just be in the moment, I would just right here open up a code editor and make some kind of black hole simulation. But no, I have to. I have an obsession with this thing called the Rubik's Cube, and I must get a little further than I did last week, and that's what I'm going to do today. So I am going to take a mulligan, make another attempt at programming this Rubik's Cube in processing with an eye towards maybe someday looking at how I might use a genetic algorithm to try to evolve a sequence of moves to solve the Rubik's Cube for a given configuration, perhaps even use some type of reinforcement learning or maybe some type of algorithm with TensorFlow.js perhaps to see if I can make a guess to which move might be the best towards a solution for any given state. Oh, so many possibilities. I'm sure none of that will work particularly well. But somebody watching this channel will be inspired to take my ideas further and do something with them. So, good news for you watching. I came in today with my cube solved already. I'm getting pretty good at it. Like the parts that I know how to do, I can do quite fast for me. I mean, we're not talking less than 5 minutes here or anything yet. But I need more time in the day to practice my cubing. Because I am a UCuber. You heard it here first. I am a UCuber. I have water, a little bit of coffee, which people in the comments like to write to me. You drink too much, please, less coffee. I didn't actually drink coffee for years. And most of my videos where I'm much too hyper, I was not having coffee. Of course, now I am having coffee because I had to get up at 6 a.m. this morning. Very early day. And I was at a Little League game last night. Quite late, till 7:30 p.m. And it was raining and I was freezing, but it was very exciting. It was a tie game, 5-5. Go blue. All right. Go O's. Shifting face to others, blah, blah, blah. All right. Hi, Mohammed from India. Where are you now, asks Derbam. I am in New York City at New York University at Tisch School of the Arts. In downtown Manhattan near Washington Square Park. My full-time day job, which a lot of the stuff that I do on this channel relates to, is teaching at a program called ITP, which is a 2-year master's program. There is also a new, as of this year, undergraduate program called IMA, or Interactive Media Arts. You can apply if you're in high school and thinking about a place to go to learn to simulate a Rubik's Cube. Actually, this is probably one of the more practical, useful things that I've done. There's so much here in what I'm about to do to learn about computer graphics, multidimensional arrays, matrix transformations. Oh, This is going to be exciting. And also, I really want to see if I could get the code. Someone suggested putting the coding train logo on one of the cubies. Did you know that these little things are called cubies? That makes me so happy. It's one of my new favorite words. Okay, now, before I get started, I wanted to highlight a community contribution that came in recently. And this is unlike any community contribution I have seen before. And so this is not one of a typical community contribution, which you might find, say, if I go to Rubik's Cube Part 1 and scroll down here and see a couple other versions of the Rubik's Cube. Hey, let's look at this P5JS one from XXNavix. Let's see what happens here. Oh, wow. Oh, toggle axis. Oh, stop. Whoa, cube size, 4, 5. Oh, look at this, rotation axis. Common. I don't know what's going on, but this is cool. Wow. All right, great work, XXNavix. That is really cool. All right, and then this one, Rubik's Cube using processing 3. So this is, I probably should look at this because I'm sure it's doing smarter things than I did in mine. So thank you. But that's not the community contribution I wanted to highlight. By the way, if you want to submit a version of any of your own code version of any of the challenges that I've done, you can add your own version and go to any challenge page. There should be some links on how to do this. And it's not the easiest thing in the world. It's a little confusing and tricky. If you get stuck, I'm here to help. Members of the community are here to help. Go to the GitHub repository, file an issue asking for help. Now, this is what I want to talk about. I think I need my ukulele for this. Oh, my invisible laptop is quite visible. What's like, oh, this is the water cup. All right, I need my ukulele. This one requires the ukulele. So I have this video series on Git and GitHub, which I probably need to revisit and redo because I use the GitHub website so much, and so much has changed, and so a lot of it's out of date. And people watching the tutorials will often file an issue or make a pull request to this Rainbow Poem GitHub repository as part of the lessons of how to work with Git and GitHub. And I'm stopping myself from explaining more about that. And recently came in a poem, an entire poem by Kyle R. Conway, which summarizes the entire video series. I'm pretty sure this moves along following the video series pretty precisely. So I think this needs to be set to song. Unfortunately, I have not prepared for this. So I have not written a song. I've read it. I have not practiced this. So probably what would be someone from the community with musical talent perhaps could put this to a tune, suggest some chords that are pretty easy to play on the ukulele. I like C, G7, and F. But I can do like a C7. I can do some other chords. That's like A maybe or something. Anyway, whatever. I can stretch for this, and we can make this into a song. Like step 1, list goals. This is a pedagogical poem. Pay attention to my lesson. Don't do it all on your own. When I type in all caps, you better open your mind, 'cause the term needs definition, so you can follow the guides. Perk your eyes, re-espresso, focus in, sit up straight. Now that I have your attention, I can pre-educate. I do a fork, I commit some changes, then I make a pull request test to the repo served at GitHub, running Git from afar. See, I need help. I'm not going to torture you anymore. People are here for the Rubik's Cube. Last week was, I think, my most watched live stream ever, even more watched than when Smarter Every Day came into the chat when I was doing the Fourier series and started trying to get everybody to come watch. The Rubik's Cube on its own, the popularity of YouTubers. There were a lot of people watching last week, and now I have lost all of those viewers. Thank you very much. So let's work on this song. We'll make a folksy music video about Git and GitHub, but let's move on to the Rubik's Cube. All right, I think I want to try something a little bit weird, which is that I think if I press button 3 here, yes, you see the little behind the scenes. We're a little behind the scenes here on the coding train. And what you're seeing now behind the scenes is me standing in front of the actual green screen. You'll also see my very high-tech Captain Disillusion would be so proud of my very high-tech. Please, everybody screenshot this and send this to Captain Disillusion. I'm sorry, I'm obsessed with Captain Disillusion. Did you see the new series about frame rate and aspect ratio? They're so good. Oh, I wish I had that talent and ability. But I do my own thing. It's my own thing. It's fine. I do what I do. Everybody does what they do. I just have to be, I am who I am. I'll be who I'll be. I've got a ukulele that I play very poorly. Anyway, look. High-tech solution for invisible laptop. It's not that I'm trying to hide the laptop from you. It's just that there's like too much stuff. So anyway, so what I think that I'm going to do is I'm going to introduce this topic of the coding challenge today about the Rubik's Cube. And let me come back to this here for a second. But I'm going to leave the green behind me because this is going to be used later in an edited version of the challenge. In which case, and then I'll add like clips of some of my failed attempts in last week's live stream, maybe behind me as I'm talking. I won't add those. Mathieu Blanchette, who is the editor for the Coding Train, will do so. So that's my plan. So if you will humor me with this, I would appreciate it. I've actually been doing this quite a bit recently. For patrons and YouTube members, I've been doing some live streams of recording sessions with just green behind me because I'm making a new series about working with data and APIs. It's coming out in May or June. A whole bunch of videos that you have no idea I'm making because I'm not doing them in a live stream, which is crazy. But join Patreon, join YouTube membership if you want to get a peek into that. Okay, but the videos will be out. Water. Here we go. Okay. Okay, I think we gotta relax, everybody. The way I relax, I think the lullaby music, I need something more zen, well, that's the wrong, it's so loud. Stop. I need little things, little wood instruments and bells that are shaking in a guided meditation kind of way. But I like to relax by reading random numbers. 71,004, 48,973, 62,054, 9,927, 67,537, 82,095, 81,855. Look at this. This is a beautiful random number. It's 12,222. Okay. I feel zen. I feel relaxed. I feel ready to tackle what has been incredibly difficult for me to make a Rubik's Cube simulation. A Japanese flute. Yes, thank you. I'll look for some new sound effects and stuff. Okay. The lullaby is way too loud. Sorry about that, everyone. It was really loud, right? I don't know why the volume is so loud right now. Hello and welcome to part 2 of my Rubik's Cube challenge. Now, if I'm being honest with you, this is actually the second time I'm trying to make part 2 of the Rubik's Cube challenge. I went down a very strange road, a road paved with all sorts of problems and bugs and strange ways of coding things with awkward switch statements and things. And I did this over a 3-hour live stream. And rather than try to actually release that as an edited version of the next step of the Rubik's Cube, I'm just kind of showing you bits and pieces of it behind me, sped through, and you can go check. That's not, let me do this again. Let's do this again. Hello and welcome to part 2 of the Rubik's Cube Coding Challenge. In this version of the coding challenge, I just want to take my existing Rubik's Cube simulation and be able to make some turns. I want to shift the faces of one side of the cubies, like the yellow faces, to turn maybe clockwise and be on the other side, and everything follows suit. So I'm going to do that with matrix transformations. Here's the thing, I have to be honest with you. This is my second attempt at doing this. I did a previous live stream where I went down a different road and I was keeping track of arrays and different arrays and trying to shift things and have like custom hard-coded things for every possible way the Rubik's Cube could turn, and it was a total disaster. In the end, I actually got it to work. You can see it spinning around and working here right now. But I had some excellent comments, most notably from Michael Raphael Panag. Here, I can actually. This is what I'm looking. The comment I'm looking at, but I'm going to keep the green screen here. I had some excellent comments, most notably from Michael Raphael Panganaban. Panganaban. I had some really useful suggestions, most notably from Michael Raphael Panganaban, who suggested that I use matrix transformations. And I'm going to try this again. I'm going to try to really think about refactoring that gobbledygook code I wrote before and trying to set myself up for success in the future. All right, so I also want to highlight this website. I am the Cube. Wait, hold on. I also want to highlight this website, I Am the Cube, made by Stuart Smith and other collaborators from Google. This was made for the Google Doodle about the Rubik's Cube a bunch of years ago, and it's really phenomenal. The code is available. I really should just not bother doing what I'm doing and just play with this, but I have a mission, and my mission is to make this Rubik's Cube turn and move, and so I'm going to do that. Okay. So by the way, this is the comment that I got. Okay, so now let me open up processing, and here is my Rubik's Cube from before. All right. Please try to use enums. I can't promise that I'm going to use enums. I appreciate everybody wanting me to use enums. The things that I can't promise are me using enums or switch statements. I am who I am, I'll be who I'll be. Amr asks, I'm just wondering, does he read random numbers in his classes? No. I mean, I would, but no. I mean, maybe I should, but I don't. I have not done that. Yes, I appreciate that people in the chat are telling me that the audio and video is not in sync. This is an ongoing problem that I'm having that I have not been able to solve yet. The only saving grace here is that when we put the videos together after the live stream, we fix those issues. So it's a little extra work for Mathieu, and someday I need to spend a day doing that. How to use enums, thank you. Yeah, we'll think about it. We'll think about it. What am I looking for? Let me cycle the camera. Okay, is this working? Yes. Let me, the camera's in a little bit off. Let's see if I turn it like this, that's better. Let me erase this, and we're going to start coding. We are going to start coding. All right. So this is what I left off with in the This is what I left off with in part one. And one of the things that I did in part one that was a little bit weird is I really was thinking in terms of cube notation. And if you're a cuber, you look at the cube in a certain direction, and you're thinking about what's up, what's down, what's left, that's right, what's clockwise, what's counterclockwise. And that really led me in some strange directions. I think it's useful maybe to double back and add that in once I have the cube working. But the thing that I'm actually working with here in this code is x-axis, y-axis, z-axis. And the thing is, well, the thing that I'm working on with the code is x-axis, y-axis, z-axis. And it's going to be much simpler for me, I think, and to keep track of things and think in those terms. And the rotation might not be clockwise or counterclockwise. It might be in the positive direction or in the negative direction. The first thing that I want to do to really figure this out and to have a more effective way is actually keep track of the cube's location, not in a vector, but in a matrix. Dun, dun, dun. So I have done a lot of videos about matrices and matrix math, and some of that's going to come up here. The ones that you might want to check out if that's the totally new concept to you is the video where I made my own 3D renderer using matrix transformations. And I made a little bunch of functions to store matrices and to multiply them. I also used matrices in a bunch of videos I made about neural networks because matrices pop up there in the math of machine learning with neural networks. But here, what I want to do is I want to have a transformation matrix for each one of the cubies to keep track of where it is in the world. And so the way that I'm going to do that is I'm going to change the cubie to have to receive a matrix, and for its position to be that matrix rather than a p vector. Luckily for me, cubelets. Oh, these are also called cubelets apparently. Luckily for me, processing already has built into it matrix classes. So I don't have to write my own matrix 3D object. I don't have to write a matrix 2D object. I've got one in processing. So it's going to be a P matrix 3D object. And so when I create the cubies, the other thing that I think I'm going to do here is I am going to keep all of the cubes in a one-dimensional array. I think there's this triple nested loop everywhere. There might be some use to that in certain aspects, but it's going to be simpler, I think, in refactoring this to actually just say, how many cubes do I need? I need people in the chat are Sorry, I got distracted for a second. I'm too easily distracted by the chat. I probably shouldn't look at it. Let me go back, actually, because I'm realizing also, I'm thinking about this. I am going to need to have these nested loops in order to initialize all of these different cubies, or cubelets, as I just learned that they're called. But I think it's going to be easier if I actually just keep track of an index and put everything in a single one-dimensional array. So hold on a second. Let me go back for a second, because I realize I want to do this differently than I thought. Okay. All right. Why am I doing this? I'm refactoring this first so I can move the stuff. The other thing that I want to do now, this is how I made the cubes before. I made each cubie with an x, y, and z. But now I want to do this. I want to make each cubie with a matrix, B matrix 3D. And then what I want to do is translate that matrix. So in other words, each cube, it's a way like each cube is going to keep track of its own 3D world. And it has the full matrix of what is the translation, what is the rotation, what is the scale. And so if I translate that matrix to its XYZ location, then I'm initializing the QB with that particular matrix. I'm also going to, well, let's leave this length. I think there's some other things that I can refactor to simplify. Remember, the whole goal of me doing this is to think about it in a different, hopefully more succinct way that's going to be easier when I need to move those things around. So I wasn't really thinking about moving the things around when I did the first version, and I made some tries, I've thought about it, got some suggestions, and I think this is going to be a good path for us. Some other things, I think that while this nested loop is useful, it's going to be much simpler for me in the end, I think, if I actually keep all of the QBs in just a single array. The multi-dimensional array is interesting, but let me change that to, I'm just going to make it, oh no, I'm not going to make this I. I'm going to make this like index. Oh, actually, let me make this, I'll make this index, and I'm going to say cube index equals new QB with the matrix, index plus plus, so that I'm counting. And then this will now be a single array that has dimensions times dimensions times dimensions. 3 times 3 times 3, or 27. Of course, there really isn't a QB in the center, but you can't see it anyway, so we can imagine it's there. Now, the other thing that's really important here, and I'm going to change, I think this will be helpful. I'm going to change this to x, y, and z. X, y, and z. And I'm going to change this to x, y, and z. I'm not going to worry about this figuring out the actual position of the cube with its length. I just want its position in a three-dimensional world. And what are those positions? So if I just think about one face of the cube, for example, maybe this is a face of the cube where z equals 1. So there's, if I get the cube, right? If we're looking at the cube with green facing us, facing you, this could be the z-axis. This is z equals 1. So we've got the x-axis along the horizontal and the y-axis along the vertical. So what I could think about this is really the location x, y, 0, 0. So it's 0, 0, 1. So all of these have a z location of 1, but this one is negative 1, negative 1, 0, negative 1, 0, oh, sorry, 1, negative 1, right? The y is negative 1, the x is negative 1, 0, 1. So this is negative 1, 0, and this is 1, 0. This is negative 1, 1. This is 0, 1, and this is 1, 1. So these are all of the locations, and these can actually be the x, y, z values that I apply to translate each individual cubelets matrix. So if I come back to the code, what I'm doing here is I'm saying have the x go from negative 1 all the way to 1. Same thing for the y. Same thing for z. Create a matrix for each one. Create the QB. I'm not going to worry about this length thing right now. And then say index plus plus. The QB then is just a thing with its matrix. And this should say P matrix 3D. I've got to specifically use, I'm going to be using a 2D matrix in a little bit. You'll see it's crazy. But right now I'm going to use the 3D matrix. All right. So look how nice this is now. Look how much simpler this is. Why am I still having an error there? Oh, I still have this length variable here. OK. The other thing I want to do is, while it was really useful that I had this whole way of doing these quads and coloring them, I'm going to get rid of that right now. Because I think that what I want to do is think of each of these QBs as a box. And then it's also going to have faces. And I think I'll draw the faces as a separate object with a quad. So right now, to keep things very simple, I'm going to show you something kind of nuts. I am going to take out all of this. I'm going to get rid of this translate. I am actually going to call this function called apply matrix. So what's going on here? If you've learned or watched any of my videos about matrix transformations in processing or P5.js, I'm always just using translate, rotate, scale, push, translate, scale, rotate, pop. All of those transformations, all the math for those transformations happens in the matrix that's the matrix that's keeping track of the world itself, the processing 3D world. But I could just apply all of those transformations to a matrix object and then apply the matrix to apply that to the world. That made no sense. Enums. People are telling me enums. Let me try explaining that again. Slow mode is not on. Slack chat, let me know. Peter asked, did you get a Pyramix? I did get a Pyramix. I got a Scube, I've got a Pyramix Duo, I've got them all. I've got them all. If I need to do anything about slow mode in the chat or anything, please let me know. Thank you to those of you who have the patience and ability to moderate right now. So in this case, what I'm actually doing, so what am I doing here? I'm taking the matrix, and I probably shouldn't call it pos as in position. Let's actually call it matrix. Let's call it matrix. Each QB has a matrix which really contains all the information about where its position and rotation in the world of the cube itself. And this is actually the same as just calling translate at this point. But because I'm storing it in a matrix instead of calling translate directly, it's going to give me some more possibilities later as I need to keep track of all of these QBs separately or in smaller groups and that kind of thing. So if I do this, and then if I just say box, and I'm going to say box 1, it's going to be a small box, pop matrix, then, and here, the nice thing about this also is I can change this to cube.length and get rid of this nested loop. I can say cube index I.show and hope that we see the Rubik's Cube. Where is it? Oh, look, I think it's there. I think that's the Rubik's Cube. Oh, it's, look, I visualized the black hole on the day of this is the second image of a black hole. No? Okay. So the reason why it's so tiny is because scale. So let me say scale 100, and let's see what happens now. Where's that Rubik's Cube? So let's think about, stroke weight 8. Now that's lunacy here. So let's make the stroke 0. Let's make the stroke weight small because I'm scaling up. And let's also make sure we say fill 255. I think that's there already. Oh, that's a really big one, but there it is. So I don't want to scale that much. Let's scale it by 50, and let's just say stroke weight 0.1. And there we go. So now I have exactly the same thing. I have exactly what I had before, but I just have a matrix for each one of the QBs. Now, I need to figure out how am I going to debug this. Right now, if I move them all around, I could move them around. They're all white. They're all going to appear in the same location. So what I'm going to do is I am going to make a variable. I'll just call it highlight false. And I'm going to say if highlight fill 0. And then let me say cube index 0 highlight. And, oh, no, highlight equals true. I didn't make it a function or anything. OK. So there we go. We can see, that one. See, look, this one is now highlighted. I can address any individual QB. It's not really highlighted because it's black. It sort of looks like it's removed. You know, I could make it, maybe I should make it like red or something, just so it's a bit more obvious because everything right now is just white. Okay, but let me actually highlight the one that's in the front because that'll be, I mean, I could always spin this around, but let's highlight the one that's in the front. So that would be, which one is that? What am I doing? I'm doing X first, Y next, then Z. Oh, this is the worst. Is it like going to be like 24? No, it's 21, I think. That's that one. 21? Where's 21? Oh, it's there. 3? That's just, this is why I should have had the, right. Okay, this is helping me. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I think it's going to be 15. I think I'm going in that direction. X's, Y's, then Z's. No, I already tried 15. No? I should just do them one at a time. Somebody in the chat will tell me. Oh, Nathan Growl. I'm happy to give you moderator privileges. How do I do that? Will you post a chat message? If you post a chat message, I can give you moderator privileges. I guess I could do these one at a time. Let's find it. Index. Let's actually cycle through all of them. That'll be kind of fun to see. So I'm going to say int index equals 0, and I'm going to say cube index dot highlight equals true. And then at the end, I'm going to say that, and then I'm going to show it. Then I'm going to say it equals false. And then I'm going to say index plus plus. Let's make the frame rate 1 and print the index. Array out of bounds exception. Oh, it's frame rate 1. How come it didn't go slow? Oh, whoops. Ah! Stop turning. 12. Oh, 13, 14, 15, 17, 18, 20, 21. Wow, it's a weird order that I didn't expect. Three! It's number 3! Why is it number 3? How come I didn't realize that? All right. It is... Oh, I made the frame rate 0.5. That's not what I meant to do. Cube index 3, highlight is true. Whoops. No. What is going on? No, it's 2. 2. Oh, it's 2 because it's the one before. Oh, it's just 2. It's going that way. Boy, I just lost like 15 minutes. I'm getting very sweaty here. Some things I can do really well, and other things it's all right. Matthew, you could edit all of that out. I used to say that and it wouldn't get edited out. Now it really will. All right, the answer, by the way, in case you were wondering, was 2. I'm counting with Z first, so it's going 0, 1, 2. So perfect. Boy, that was a lot of time I spent trying to figure out that it was 2. You're lucky you didn't have to watch that. Okay, so now I can see that I'm highlighting a given QB. I forgot what I was doing this. Okay, yes. Just thinking about this for a second. Yeah. Okay. Okay. Sorry, I'm thinking about this. Okay. I'm thinking about this because I did this a week ago, and I'm not sure I love the way that I did it, but I'm gonna keep it that way for right now. So let me rotate along the z-axis first because it's gonna make the most sense. Okay, so I'm gonna do that. Okay. 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 All right. The next thing that I want to do is take one of these faces. Each one has its own 3D matrix with an x, y, and z, and rotate it. I want to apply a 2D rotation to this particular face. So any face, whether it's the front, the back, the top, the bottom, if we look at it, it ends up becoming two-dimensional. So I just want to rotate along one particular axis. And so a way that I could do that is actually take any given face of the cube can become a 2D matrix. Any given face can become suddenly a 2D world that I want to do a rotation to. So if I suddenly have this point here, which is at -1, -1, and I want to rotate that relative to the center 90 degrees, or half pi, then it's going to end up where? In 1, -1. It's going to move and rotate there. So how can I do that? I can apply a 2D rotation. So let's look at how I would do that. If I come back to the code, let's write a function called turn z. And I want to avoid using rotate z because even though I'm doing a z-axis rotation, rotate z is a built-in function in processing. So if I say turn z, first let me look at all of the cubes. So I always need this particular loop. I'm starting to regret that I kept it because I could actually just do the loop along the z-axis, but whatever. I'm going to do it this way. And what I'm going to do is I'm going to say, oh, I see. I see what I'm doing here. Oh, I see. Just realized something. I sort of regret, I'm regretting taking out that nested loop because I just want all of the faces that are in the z-axis. And if I had that nested loop, I would be able to keep it that way. But actually, I'm going to do something slightly redundant, which is that I am also going to keep track in a separate variable. I am going to keep track of I'm going to keep track of its x, y, and z index values. I'm going to keep track of what those values are within what would be a three-dimensional array. And so let me actually add those as arguments here. And I'm going to say x equals x, y equals y, z equals z. And then when I create each cube, I'm going to say x, y, z. Great. So I have those extra variables because now I can say if cube.z equals 1, right? I want only the cubes that are in the z-axis 1, -1, 0, 1. Those are the ones, and this is cube index i.z. These are the ones that I want to rotate. So now I need to make a 2D matrix. This is what I was saying. 2D matrix out of that face. So the 2D matrix is just a new 2D matrix. I want to do a 90-degree or half pi rotation of that matrix. And then I want to translate out to the cubes x. And let me actually, let's use a variable. I saw somebody on CodePen I saw Spungman Sponge Man. I know. People are giving up. I'm kind of going backwards and forwards. Sponge Man on CodePen, who made a version of this, I saw used actually a really cute variable name, which I'm going to use right now. QB, like the letters QB for the QB, equals cube index I. So I can actually just use QB. If QBZ equals 1, translate by QBX and QBY. Essentially, what I want to do here is I need to rotate before I translate. I have this thing here, I make this matrix, I rotate the matrix, and then I translate out to here, and I have my new location where X and Y should be. So what is going on here? Let's look at, I think I'm going to need to do some console logging here of this. I think in order to make this more clear, I want to do a little bit of console logging. Because what with this matrix, like what's actually in there? So let me first I'm going to call this matrix 1 and I'm going to call this matrix 2. And this is just for debugging purposes. And I'm going to say matrix 1.translate QBX QBY. So I want to show you what does it look like when I just apply this translation to X and Y without a rotation, and what happens when I rotate and then apply that translation. So to show you that, I can do matrix 1 print and matrix 2 print. Processing is a nice print function associated with matrices. And let me also just do print line something like this. And let's also, just so we can see, do print line QBX, QBY. So we can see what those values are. So let me run this. Oh, I need to call this function. I'm going to call turn z right here in setup. And now we're going to look at all these. Look at this. When the x, y location is -1, -1, you can see it as the third column in rows 1 and 2 of this matrix. Right? This is the matrix that keeps track of translations and rotations for a 2D world in processing. When I rotate it 90 degrees, where does it end up? 1, -1. -1, -1 ends up at 1, -1. Ha ha! When it's -1, 0, it ends up at 0, -1. When it's at -1, 0, rotating 9 degrees, it ends up at, where did it end up? 0, -1, which is right here. So you can see this rotates to here. So actually in those matrices are the new index values of where it is in my sort of 3D array that I'm imagining. So here we go. And these values are all stored in properties of the matrix object, which are indexed by its row and column. So I can basically say, right, I don't actually need this matrix 1. I did that just for debugging. So I'm going to leave some of this debugging stuff in here. I can basically now say, hey, QB, you have a new location. Update your location to matrix2.m. I think it's row column. So 0, 2, matrix. This is matrix 2, M2. Basically, I'm getting, and I could have just done the matrix math with like sine and cosine probably, but I kind of like the idea that I'm using the built-in matrix math of processing. So you can see here that these are these two values. Update by, M12, and then qb.z, because I'm not affecting the z. So there's no update function, but this is really what I'm doing. There's no update function yet. That's a new thing I have to write, but this is what I'm doing. I'm taking the x, y. Actually, I want to get rid of the debugging stuff because this makes it so much simpler to look at now. And I'm just going to call this matrix. I don't need matrix 1 and matrix 2. What I'm doing is I'm making a 2D matrix out of the x, y, then I am rotating it, and then I am getting the new x, y, and replacing it, in theory, in my QB object. And in my QB object, then, I need an update function, which does something like, first of all, I'm just going to, there might be a more thoughtful way of doing this. So I'm just going to reset the matrix. And this needs an x, a y, and a z. And I'm going to, someone in the chat was telling me, and I should probably get a habit of doing this, if I have the same variable names of things, I can make sure I'm referring to the object instance variables with this dot, which is, of course, the thing I like to use on this channel. Let's be consistent and do it here. So I can say matrix, I don't have to say reset matrix. Matrix reset, matrix translate, x, y, z. And then let me update. Again, I've got like a serious bit of redundancy here, but let me just update those x, y, z values as well. So now, this should update. Why is update not working? Oh, you know what? These values in the matrix are floats, and QB wants an int. So I'm going to, I could just convert it to an int, but I'm going to use round, because I want to make sure. I ran into this in another project. Just in case like it for some reason gives me like 0.999999999, it would, if I used converting it, casting it to an integer or floor, it would make it 0. So this should work. Let's get rid of turn z here, and I'm going to add key pressed. And I'm just going to say if key equals just the key 1, turn z. So now, all right, ready? When I press the key 1, that QB should move over to the right. Oh, it worked. Oh, that was a little bit anticlimactic, but it works. Now, here's the interesting thing. I should now be able to say, give this turn z an index. Whoops. Int index, which would be here. So for example, now if I were to say turn z 0, else if key equals 2. I know you want me to use a switch statement, everybody. Turn z 1, right? I should be able to rotate. The middle is technically, while I could program it with a rotation of the middle of the cube, that's not really a thing. So I'm actually just going to use 1 and 2 to rotate 0 and 2. Let's highlight both cube 2 and cube 0, and let's see what happens. So I should now be able to, if I press 1, whoops, oh, what happened here? If key equals 1, is that actually happening? Hold on. This is world sophisticated debugging going on here. What did I do wrong? Wait a sec. Oh. Oh. Sorry, everybody. The indices are -1 and 1. -1, 0, and 1, of course. All right, let's try this again. Get rid of my print line. Hello? All right, here we go. Right? Oh, is it going around? Look, there it's going around. Look at that. That one's going around. It's going around. Look at that. It's going around. Yay! Yes. Okay, now look at this. Now there's got to be some sort of way I could make this function into any, I could like keep this function generic and do any given axis, but that's too hard for me. I'm gonna, this will definitely. I will refactor this later, you know. But right now I'm just gonna copy paste and I'm gonna say turn y. And so now if y equals index, then what I want is x and z. X and z, QBY. I don't need to actually round that. So this should be exactly the same for a y rotation, right? And then, oh, and I need, I'm going to add one more thing. And then x, I'm going to just check the x-axis, and this should be y and z. Then I need to keep QBX and adjust the y and z. So I'm turning any face like this here with turn y. Now, it was kind of obvious to us that when I have the x-axis, that I turn this face into a 2D matrix. But when I'm using the y-axis, let's just take this face and turn it into a 2D matrix. I need the y values and the z values. I mean, sorry, the x values and the z values. That's what's changing. Y is fixed at -1, 0, 1. So this should allow me to, all right. I'm going to use a switch statement. Switch statement. I'm looking up the syntax for the switch statement over here. Okay. I'm probably going to have to come back to my if statement, but I know it's just too painful. I can't bear to deal with the comments. Switch key, I'm looking at it over here on my invisible computer. Case 1, case 1, turn z -1, break. Right? And then I just keep doing this, right? Case 2, turn z 1, right? And then, all right. Now, actually, here's the thing. Let's see if I can get clockwise and counterclockwise. There's how many moves, right? I could rotate in this direction or the other direction. So I'm going to consider that to be a direction in my rotate. Well, let me just get this to work first. Then I'll add direction. It's too many things. Case 1 and 2. Case 3 and 4, which is turn y. Case, whoops. Whoops. Case 5 and 6, which is turn x. No? Yes? Is that a switch statement? Oh, I know. Some of you I just can't bear. All right. Is that actually a switch statement? What's the chance that that's actually a switch statement that works? Okay. So 1 is just turning the back row. That still works. 2 is turning the front row. Oh my God. 3. That's not right. Is that? That doesn't look right. Hold on. X. 4. We can't see that. 5. All right. So something's wrong. All right. Let's take a look. What did I get wrong here? So y, this should be a y rotation. So I should see if I'm doing a y rotation, this should end up here and this should end up there. Oh, that is right. That's correct. I just didn't see it. It's totally correct. It's correct. It just looks weird. That's y. Thank you very much. And x, right? Yeah, that's right. No, that's z. Now x is rotating around the, all right, x, 4. 4 does nothing. No, x 5. Oh, that's right too. I need to make those different colors. So let's do something a little different. Let's give these a color. And let's do the following. Let's set the color equal to red and the color equal to, oh, this is just C. The color equal to blue. And then in the QB itself, let's just fill it with its color. That makes much more sense. So now I think it'll look right to us now. So if I go and do a Y rotation, right, that's correct. Now here's the thing. Will this all keep working? Will this continue to work if I do multiple combinations? So let's do my Z rotation, where now that's there. Now let me also rotate that there, but let me put it down here, or let's just leave that there. Now let's do a Y rotation. Yes, that still works. Let's do X. Yep, that one's going around there, and then the red one is going around. The cubes move correctly. Now that I have all this working, I just need to color, now that I have all this working, I need to actually color the faces correctly. So if I put the actual colors of the cube on the faces, then I can start to move those as well. So in order to do that, I have an idea. What I would like to do is I would like to make a face class. And what I'm going to do, the face class, oops. Why is the... Well, it's 11:30, getting close. Wait, come on. Sorry, I think I have a loose cable here, everybody. Sorry. There we go, just a loose cable. The idea of how I'm going to keep track of a face, so every single QB will have, in an actual Rubik's Cube, there are centerpieces which just have one face and they never move. They spin, but they just stay permanent. There are these corner pieces which have 3 faces, and I don't know what these are called. These little middle pieces. I'm sure there's a tech name for them that have 2 faces. I'm going to be simple about this for now, and I'm just going to give every single QB 6 faces. And there's going to be a lot of redundancy. Like you'll never see the fact that this QB does not actually have a white face on this side, but I'm going to give it that. And the way that I'm going to define each face is going to have a color, like what is its actual color, and it is going to have a normal. So its normal is a vector that points perpendicular from the face. So if it's the front-facing face, its normal will be 0, 0, 1. It's pointing forward in the z-axis. If it's the backwards-facing face, 0, 0, -1, to the right, 1, 0, 0, so on and so forth. So here in the face class, we're going to have a p vector called normal, and then we're going to have a color called C for color. And when I make the face, I will give it a normal and a color. And I will say this dot normal equals normal, and this dot C equals C. Then every single QB, in addition to having all this information, will have an array of faces with 6 faces. Again, a thing that I would want to do later, and maybe you can do this in your version, is to have the correct number of faces for each QB. But let's just do them all with 6. And then in that case, I'm also just going to hard code this. So each face faces index 0 would be left. So I'm going to consider the z-axis as green forward. So the back is blue. The -1 is 0. So that's going to be a new face with a new p vector that is 0, 0, -1. And the color is 0, 0, 255. So, right, so this is the blue face. This is the green face. This is, wait, up would be 0, 1, 0. This would be white. Down. Yellow. How do I do yellow? It's a little red and a little green, something like that. No, red, a lot of red and a red and green. Green, yeah, but this is 0. Okay, that's yellow. For yellow. So then left and right, positive right is orange. 1, 0, 0 is, well, I think that should be orangish. Somebody will get in the chat, will give me some better colors. And then the other side is red. So this is now me making all of the faces. Great. And then guess what I get to do here in show? After I apply that matrix, I can draw all the faces. For face f in faces, f.show. And now all I need is a function here that knows how to draw a rectangle pointed perpendicular to the normal with a particular color. How do I do that? 255, 255, 100 is yellow. Up is yellow. I know. All right, how am I going to draw each face? I've lost the chat here. Oh, yeah, I also need to add the reverse rotation. I will do that. For each for the win. How can you use tint on a box? All right. So the first thing that I know I need to do is fill the color. Then I need to draw a quad or a rectangle. Let's just use rectangle. Let's just try using, I'm just drawing a 2D rectangle. And I need to rotate it according to the normal. Let's just draw the rectangle. Rectangle at 0, 0, 1, comma 1. Actually, it's a square. I can use processing square function. I think its size is just 1. So what if I do this? Oh. Okay, first of all, let me go back to my QB, and let's just say no fill. Well, there's the red one. It's in the wrong place. Oh, they're all just on top of each other. Right, of course. Oh, I do need to translate out. I do need to translate. I can translate by the normal. Oh, of course. Okay, so I can translate by the normal.x, normal.y, normal.z. And I'm going to want to add push matrix and pop matrix. And let's do no stroke here. So now that should be, there they are. They're all the faces, sort of. Are they in the right place? They kind of are, right? White is back there, yellow's there, then blue, then red. But they're all, the problem is they're all not, I need a rotation. Can I rotate like along the normal or something? Like can I do something like say rotate normal.x, normal.y, normal.z, half pi? Is that like going to work? No. To think about this. Oh, is it? Oh, maybe it's the other way. Maybe half pi goes first. That's the angle, and then this is the axis of rotation. Oh, Oh, look at this. Something's right, sort of. First of all, they're I should be translating by normal x half of that. So let's multiply all these by 0.5. Okay. Green and blue, are those on opposite sides? Yes. White and yellow are in the right orientation. Everything's in the right orientation, but they're in the wrong place. Oh, do I need to? Oh, I should translate before I rotate. Okay, closer. -1. That's a -1, right? Okay, now I'm really close in the sense that orange, no. These all have the wrong, the way I'm doing the rotation is not right. You need the angle and axis of rotation will become your normal vector. Yeah. Yeah. Don't copy paste, kids. Yeah. All right. Well, I know there's a way I could do this. I was trying to avoid this, but just so I get it right. If I were to say, if normal.x, if the absolute value of normal.z is greater than 0, right? If the normal is along the z-axis, I need to rotate. I actually don't need to rotate at all. The rectangle is drawn correctly. So I could say like rotate rotate z, by half pi. Else, if the absolute value of normal.x is greater than 0, then I could rotate, I think it's by x. Else, if absolute value of normal.y is greater than 0, there's got to be a better way, but this will work, I'm pretty sure. Then I can draw the face. That's the same thing. Oh, wait. Translate and then rotate. Right? Look at the chat. Dot product. Rotation should come first. Oh, right. What if I just do, I don't need, so close I am. I know another way to do this. I think rotating is, oh, well, no. I want to translate out, and then I want to rotate according to where I am. Do I have this wrong? Oh! Oops. Okay, so of course, if I'm along the x-axis, I want to do I'm drawing the quad like, I'm always drawing the quad face forward. So if this is my quad, if I'm it's here, along the x-axis, I need to actually do a y rotation. If I'm along the, so of course, so that's it. So what I needed to change here was and this doesn't, since I'm drawing it forward, I can just basically skip the whole z thing. So I only need to do a rotation. If I'm on the x-axis of a y, if the normal is along the y-axis, rotate by x, and then, here we go. Now, we have the Rubik's Cube, and guess what? I can turn it. Wait. Huh? So now I'm turning it, and nothing's happening. Guess what? Now that I have these faces, what happens when I actually turn a Rubik's Cube? The faces also rotate. The normals need to rotate. This is the last piece. I want to animate it turning, but this is the last piece to at least have it so that I can do all the moves. Oh, and actually I need to add directions and maybe make the keyboard controls make a little bit more sense. So now what I need is inside the face, I need a turn X, I need a turn Y, and I need a turn Z. So I need to be able to rotate any given face. I saw the chat just went a little crazy. Yeah. So once again, I can just use matrix transformations. So once again, I can use matrix transformations, only this time, and I've done this before. I did this in my video about doing 3D rendering without the 3D renderer with our own matrix math. And so what I need to do here, let me pull up the Wikipedia page. No, I want 3D rotation. Where is that? Here. This is basically what I want to do. Where was I looking for that where it has all three rotation matrix? That's what I'm looking for. Ah, there we go. This is what I'm looking for. Yep, here we go. So here they are. These are the three rotation matrices for doing an X rotation, a Y rotation, and a Z rotation. And all I need to do is apply those rotations to the normal vector. So I'm sure I could use P matrix for this, but for whatever reason, I think I might have an easier time just writing this out, because ultimately what I'm saying is, let me make a new P vector. I'll just call this V2. And then v2.x equals the normal.x times sine. So I need an angle here. Right, sorry. Normal x times equals normal times x times cosine of the angle plus or minus. Formulas are here somewhere. What is it? Where's that formula? Minus v1y times sine. And then it's sine plus cosine. normal times x times normal dot x times cosine of the angle minus normal dot y times sine of the angle, and then v2 dot y equals normal dot x times sine of the angle plus normal dot y times cosine of the angle, and then v2 dot z equals z. And now I should have, and then I can say normal equals v2. So I have just rotated the normal according to the x-axis. Oh, equals, actually this should be normal, sorry, this should be normal dot z. Now here's the thing, I'm a little worried we're going to run into some rounding weirdness. So what I probably should do is say, let's just put round around all of these. I think that will kind of do the trick. I just don't want to be stuck in a situation, because I really just care about 0, 1, 1 becomes 0, 1, 0, that kind of thing. So this should be turning the phases. And if you, this math I sort of did by looking at the formula a little bit by memory, but I go through this particular formula in detail in that other matrix transformation video. So now, and somebody in the chat will point out if I'm doing it wrong. So now I should be able to take exactly this same thing and put it in turn y. And the difference is, with turn y, I am changing x and z. So this is x times cosine, and this should have also a float angle. This would be x, and this will be z. This will be, this is z, this is x, and this is z, and this is y. Right? So that's just the matrix take and apply to x and z, because y, if I'm turning along the y-axis, y stays the same. Oh wait, this was z, by the way. I don't know what, I got them in the wrong place. This was z because z is fixed. This is y because y is fixed. And now, let me copy this into here, and this will be x. So x is fixed. This is y, y and z. This is z, y and z. So I think I've got this right. Yikes. I think this should turn all the normals. And if it's turning the normals, they'll display correctly. So what's a rotation that I'm doing? So how do I have this working? When I say turn z, for example, I say QB update. So I should also say here probably QB turn faces z. Let's just do that. This is, yeah. I mean, this is awkward naming, but I need to, I need to turn the faces. I'll do that afterwards. It doesn't really matter which. And so then I would add a function here, turn faces z. And I would say for every face f, faces in faces, f dot turn z half pi. What's the chance this works? Very little. Oh, wait a sec. Wait a sec. That's right. Orange goes to there, goes to there, goes to there, goes to there. Yes. Oh, that one's working too. Right? 1, 2, 1, 2, 1, 2, 1, 2. God, so close. All right. So I need turn faces y. And again, I think there's probably a way to refactor this so that these functions turn faces x. Okay, let's do y, which was, oh, no, that was x. Wait. Oh, wait. I need to call those. Turn faces z. Turn faces y. Turn faces x. And I forget what my key commands are. By the way, guess what? We can get rid of this thing, all this nonsense that I had before. I'm not using this anymore. My code is so much nicer. Okay, so now, where's my key commands? Let's just put this in its own tab. I'll just call this controls. And there's clearly going to be a better way to do these controls, but this will help me remember. So right now, if I do Y, this should be the top, 4. Well, that's the bottom, but that's fine. 5 is X, 3 is the top. 3, and then can I start combining these? Yeah. I'm shuffling the cube. I think this is good. I got to do some real testing of this to make sure this is really working. But the one thing I need to do is I need to add direction. So I need to be able to add a direction for turning it. So in these turn functions, I should also have a direction. So each one should get a direction. Then the direction is half pi, direction times half pi, and turn faces z with that direction. So rotate according to the direction, and then rotate according to the direction. So now in turn faces, these should all also have a direction. So I should be able to go either direction. Okay. And then now, all right, so let's think about this. So Z is forward. So let's use F. What's a good set of key commands for all the moves? What's a good set of key commands for all the moves? Oh, I don't want to use WASD because that's going to confuse me. I mean, So I have forward, back, left, right, up, down, but then I have clockwise counter. I guess I could use shift. I'll just use lowercase and capitalize. Okay, I'll use lowercase and capitalize. All right, so all the moves that I have are forward, back, up, down, right, left. So I'll use those keys. And lowercase will mean a positive direction, uppercase will mean negative direction. So the case F is turn Z, 1, 1. The case capital F is turn Z, -1, -1. That's forward. Then case B would be also turn Z, but 1, 1. And B would be 1, -1. All right, I'm going to do this silently, and this could get fast forwarded if it needed to. So that's front, front, back, back. And then, so let's do up, up, down. One, -1. That's, oh, and these should be Y. Up, up. Oh my God, what's going on? Forward, forward, backward, backward. Up, up, down, down. Left, left, right, right. So let's see. Turn Z, F, F, B, B. It's all turn Z. -1, -1, 1, 1. 1, -1, 1, -1. I'm going to be consistent about this. Up, 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 down, down. 1, 1. Up is 1, 1. So this should be, just to be consistent. And down is bottom 1, -1, Y. Left, I guess I should do whatever. That's fine. Left is -1, 1, -1. Right is 1, 1. It should be 1, -1. Let me make this. Comments are your friend. I mean, front is really the positive number. Up is positive, right is positive. All right, I have now put in every possible move. Front is turn Z with a Z of 1 either direction. Back is a Z of -1 either direction. Then Y, then X, so then up, then down is Y, then left and right is turn X. You know, it does occur to me that I could just have a generic turn function and I give it the normal vector of the axis, or the vector of the axis itself. But anyway, this I believe should work. Let's see. So if I want to do a front, I should just see that front face, which is the green face turn, which I am seeing. Back should be the back face. Up, oh, the up I got is down. So up is down, whatever, because I have the Y points in the other direction. Down is the top. You know, spin it around. Up is the top. As long as I'm consistent, down goes this way, right. Okay, now this is right and left. Now, are my clockwise and counterclockwise things working? So front, which was the green face, goes this way, and capital F should go the other way. Yep. So now let's see. If I turn front, and then now let me do the left, oh, that which is there. That's the right. Doesn't matter as long as it's one side. That's working. I think this is good. Here's a way that I could test this. What I'm going to do now to finish off this video is run a set of moves, shuffling it, and then run those moves backwards. And it should unshuffle it. If that works, then I think I've done it correctly, and then I'll be ready to animate this. So to do that, let me make a car array. All moves is just F, front, back, up, down, left, right. And I can deal with the capitals. You know what? I should make these individual strings, because then I can use the to uppercase function. So what I'm going to do, and then I'm going to make a string called sequence. And what I'm going to do is in setup, I'm going to say for int I equals 0, I is less than, let's just do 10 moves. Sequence index I equals int, so let me get an index, which is a random number between all, that's an index into the all moves array, sequence plus equals, I'm already using index. So let me just say R, sequence plus equals all moves R. So if I do that, all moves, this would be, you can see there should be a sequence here. You can't really see that. This is my sequence. Up, forward, right, left, up, right, down, back. And just for plausible deniability here, let's just say if random, I'm going to give random is less than 0.5. We'll do this. Otherwise, we'll do that to uppercase. So now I should have my sequence, and there you go. There's my sequence. Down, up, down, forward, up, back, left, left. Okay. So now what I want to do is I want to run through that sequence. So what's this index? That was for something else, right? I don't need that anymore, do I? So I'm actually going to use that int. I'm going to use counter equals 0. And I'm going to say in draw, car move equals sequence car at counter plus plus. And I'm just going to do this if counter is less than sequence.length. Okay, if counter is less than sequence.length, I'm going to get the move, and then I'm going to do apply move move. And now in controls, this should really be apply move, car move, and then switch move. So I could, if I want to control it by key pressed, I could still say key apply move key, but I don't want to control it by key pressed. I want to control it by these moves. So let's run this. It did it really fast because, see, the problem is the rendering engine takes a minute to spin up. So I'm going to do this. I'm going to say Boolean started equals false. And then I'm going to, you know what? Let's just change the frame rate. No, because I want to be able to turn it around. Boolean started equals false. And I'm going to say in key pressed. If key equals the space, then started equals true. So if I press the space bar, start things going. And then I'm going to say here in draw, if started. So it won't do the shuffling now. It won't do the shuffling right now until I press the space bar. Because it shuffled it. But let's slow that down just so we can see it. If frame count modulus 20 equals 0. That's going to only do that every 20 frames. So I hit the space bar. And you can see it should be, it should be doing this sequence right now, right? It should be doing that sequence. So when it gets to the end of the sequence, I should go backwards through the sequence. So if sequence is less than, here's what I'm going to do. After I make this sequence, now I'm going to say for int I equals 0, I is less than sequence.length, I plus plus. Now what I want to do is say, now I need to say that move, but the other direction. So car move, string next move equals sequence car at I. Oh, but I want to go backwards. So I want to go from sequence.length minus 1 all the way down to 0, I minus minus, and then I want to get each one of those characters. What's wrong with car at I? It's not a string. It's so I'll just convert it into a string. Can I do this to? Oh wait. Oh, how do I flip the case? Ugh. How do I flip the case? Because I can't just do 2 lowercase or 2 uppercase. How do I flip the case? 6-bit of the string, XOR with 32. Subtract some value, but I have to add or subtract based on what it is. XOR 0x32. I don't think you can do XOR in. Oh yeah, I like that. I like that. I like that. All right. So somebody just gave a suggestion. Who was that? I like this crazy way of doing it. Maxime in this chat. Thank you to MC Seam in the chat who just gave me a really nice suggestion. I'm going to say flip case sequence car at. So I'm going to write my own flip case function. It's going to be kind of ridiculous. Flip case of car, any given character C. And what I'm going to do is so first I need to make it a string. Sure, I could just do that. If I know it's lowercase, if it equals itself, right? If the lowercase version of the string is the same as the string, and I think I want to say it this way, if s equals s, this is just a little clearer. If s equals s to lowercase, then return s to uppercase. Otherwise, return s to lowercase. And people were giving good suggestions about using XOR, flipping bits, or adding the ASCII values. That would be a nice way of doing it. Apparently, that's not a way you can make a string. I'll just do this. I think that works. That's one way to make a string. Okay. Plus equals flip case. Oh, no, just next move. Oh. So, next move, yes. Next move equals flip the case and then sequence plus equals next move. All right, let's have it shuffle pretty fast, like every 5 frames, and let's see what happens. I got an error. Oh, plus equals. I don't know if you don't need any parentheses there. Oh, I have to hit the space bar to start it. Shuffle, 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 shuffle. Reverse. Let's do, let's finish this off with just doing like 200 moves. Let's forget about slowing it down. And let's just enjoy this beauty. Let's make it full screen. And thank you for watching part 2. Oh, I have to space bar. Thank you for watching part 2 of my Rubik's Cube coding challenge, where I am now shuffling the cube, moving all the pieces around, then unshuffling it backwards to make it appear as if it's solving. Of course, it's not actually solving itself. It's just doing a sequence and then turning it back, and there we go. So the next step that I need to do is I want to see it animate. I think it'll be much more interesting to actually watch the faces themselves turn. So that's just a little animation thing. That'll come in part 3. Once I have that, then I can start to think about, are there different techniques that I can try to apply to have the cube solve itself automatically? Thanks for watching this very long part 2. If you make your own version of this, if you figured out clever ways to refactor my code, to visualize it in interesting different ways, to make it more generic with different scales, maybe you can make one of those pyramid, it's not a cube, those Rubik's pyramids. Oh, that would be great. And I'll see you in a future video. Goodbye. Yeah, okay. All right, so I'm going to take a break in a minute. And I'm gonna do the animation part today. It's 12:15. I've got a little more time in me today. And I'm gonna do my sponsor segment now. and then take a short break, and then come back and do the animation. And yes, genetic algorithm is the first thing I'm going to start to do. I'm recording this to disk. I've got green on the stream. I've got my Rubik's Cube here. I hope there's not a mistake in here. There easily could be a mistake. I haven't really looked at this super closely, but the code is much, it's problems, but this is better. This is like, there's more to work with here. All right, so I'm going to tell you about Brilliant. Brilliant is the sponsor of, Brilliant.org is the sponsor of the Coding Train live streams. For the last several live streams, I've been really enjoying this collaboration and really thankful for this opportunity to have this sponsor. Brilliant.org is a website that has a lot of daily problems in math, science, computer science. There's lots of interactive courses, algebra, quantum computing. I'm sure there's going to be some stuff about black holes on Brilliant sometime soon. I wouldn't be surprised. And what I like about Brilliant is it's a chance, one, I use it for now looking through it and getting ideas for things to do as coding challenges, but it's really a way for me to practice, to learn through practicing. And I've really especially also been enjoying the discussions that I find about people's solution to problems. So last time, a couple weeks ago, I looked at Brilliant and looked at, what was the thing that I saw? Oh, right, it was a problem, a set theory problem. Which looked at the intersection between multiple sets, and I made a P5JS sketch that visualized it. And Brilliant has a lot of computer science courses now. Let me go to the website. And this is probably the stuff that would be the most relevant to what the kind of things that I'm doing on this channel. Computer science algorithms, computer science fundamentals. And what I want to highlight, what I like to do now during the sponsor segment is to pick one of these challenges and try to solve them. So the one that I think what I'm going to do is so this is the challenge from today. It's about decision trees. How long is this journey through the trees? Maybe we'll come up with an answer in the next 5 minutes or so. But I'm going to actually step back for a second. So this is a little trio of challenges. It started on Monday with computer classifiers cataloging ceaselessly. So if I go to this one, and this is looking at a decision tree. So I just want to talk about decision trees. And the coding challenge that I have that's the most similar to this is probably the binary tree challenge. And I should probably do a video on making a decision tree. So let me get the whiteboard going again. And find my marker. So I'm going to go through Monday's challenge and Tuesday's challenge. And then I am going to talk to you about today's challenge, and then I'm going to take a break, and if you're interested, you can sign up for Brilliant and put your answer in there. So here's the thing. I have a coding challenge all about binary search trees. A binary search tree is a data structure for storing info. Oh, I'm not in the right... Hello, I have a coding challenge about binary search trees. So a binary search tree is a data structure for storing information in a binary tree. And if the information I'm storing, for example, is numbers, I might put numbers that are bigger on the left side and smaller on the right side, or vice versa. Text, I could do it by alphabetical order. And so visualizing a binary tree might look something like this. And the information is going to be in sorted order and make it easier to search through and find things. So you can go check out, I think it's Coding Challenge, I don't know what the number is, where I do a binary search tree. A decision tree has this same exact structure, and it's really good to think of it like a flow chart. You've seen these, where you're answering yes or no questions. So I might say something like, if I were trying to classify animals or fruits, these are you can use it for a classification or actually a regression problem. I should definitely do videos on this. So a decision tree, for example, if I was trying to classify animals, the first question might be, is this what the example on Brilliant is? Oh no, they're using bigger than a bread box, literally a bread box. That's much funnier and more clever than me. Let me come up with some animals. So I might say, do I have fur? So if I say yes, I would go in this direction. The question here is fur, question mark. If I would say no, I would go here. Then I could either arrive at the answer or another question. So fur, I might say now, do I walk on, I don't know, am I bigger than a bread box, right? Bread box. And if I were to say yes, then maybe I am what's an animal bigger than a bread box with fur? a large puppy. I really did. I'm so bad at coming up with these examples on the fly. I should have done fruit. I'm really much more familiar with fruit. So if, let's say I say no, then maybe I'll say mouse. You know, mice have fur, right? So this would actually be known as a leaf. It's no longer a question, it's actually an answer. You've arrived at a leaf. And these are nodes. So a decision tree, you can either have nodes and leaves, and these can be quite complex. So let's look at this first challenge. So if a decision tree, I've actually already answered this one. Oh, good. I've already answered this one. And this camera went off. So I won't scroll down too far to reveal the answer. But a decision tree has 15 nodes. How many leaves could it have? So we could diagram this, right? If there's 15, there's actually a relationship between the number of nodes and the number of leaves. A binary tree can kind of have any number of things, but so if they're like let's oh, I'm not on the whiteboard again. So there with a decision tree, so there's what was the question? 15 nodes. So we know there are 15 nodes. So if there are 15 nodes, how many leaves are there? I'm looking at, leaf nodes could it have? I guess the question that I'm asking now is, so actually in this case, we're talking about total nodes. So all of these are nodes. So I'm actually describing it a little bit differently. All of these are nodes, but 3 of them are leaves. So you can see there's 5 nodes, but leaf nodes are the ones that have no children. So in this case, if there are 15 nodes total, and this is going to reveal what is the relationship between nodes and leaves. So there are kind of 2 extreme cases we could look at a diagram of a decision tree. And this has to do with like how trees are balanced, balancing trees. Let's make a perfectly balanced tree with 15 nodes. What I mean by that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Oh, how nicely that works out. Excuse my poor drawing here. But you can see there are 15 nodes. How many leaves are there? All of the leaves are all this bottom. This, by the way, is a term that's known as depth. So the depth of this orientation of the decision tree is this depth 1? Is this 1? I don't know whether I should count from 1 or 0. But let's say we count from 0. 0, 1, 2, 3, 4. So it's either 4 or 5, depending on how it's technically referred to. And I'm probably on brilliant or a Wikipedia page, we can find that out precisely. But this, how far is the depth? And we can see that there are 1, 2, 3, 4, 5, 6, 7, 8 leaves. So, but what if I do the tree in a different orientation? Let's take the most extreme unbalanced version. Like what if this is the root? If I answer yes, I'm going here. If I answer no, I've already got a leaf. So this is a leaf. So then here, if I answer yes, here, no. Yes, no. Yes. So this is like, the depth is this is as deep as it's going to get. So let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Oh, I'm going to run out of space. 14. I will just go higher. Oh, but I messed that up. All right, there's one more. Can you see this here? Oh, it's perfect. I have just the right amount of space. 15. Right? So look at this. These are all the questions. Yes always leads me to another question, right? This is question, 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 question. And these are the leaves. 1, 2, 3, 4, 5, 6, 7, 8. Once again, there are 8. But the depth is 1, 2, 3, 4, 5, 6, 7, 8. So the depth here is 8. The depth here is 1, 2, 3, 4, 4. So you can see how, no matter how the tree is organized, we still have 8 leaves. 15 nodes total, 7 question nodes, 8 leaves. So if we come back here, we can see, oh look, I got it right. Yay! So now we can move on. Let's move. So that's. I would love to program this, and we could visualize it. That's the thing that I would love. You should tackle and try. I like to program little JavaScript versions and then take a screenshot and put it in the answers. You can see here. Okay, so this is a nice, by the way, answer that's like going through the same exact thing with some formulas applied. Let's go to Tuesdays. What questions lie deep in the trees? So I'm going to stop here. I'm not going to scroll down. Oh, wait. Oh, no. Ah! Oh, sorry. I can't reveal the options without showing you the answers. But it's fine, because I already looked at this, but that's OK. You have a decision tree with 2,000 leaves that allows you to distinguish 2,000 different animals. Which of the following could be the depth of the deepest leaf in the tree? Select all that apply. Oh, and look at this nice, helpful guide. So we should be able to have a way of figuring this out, right? If there were 8 leaves, this would be the minimum depth. If there were 8 leaves, this would be the minimum depth. This would be the maximum depth. 8. So one thing we can know is the maximum depths, if there are, what did we say there were? 2,000 leaves? The maximum depth, the maximum depth, I can't say it, the maximum depth, such a hard word to say, especially if you've been talking for 2 hours straight, would be 2,000. Because we're gonna, the first answer would be at depth equals 1, then 2, then 3, then 4, then 5, then 6, then 7. It's actually 1 less. I guess it would be 1999. If this is counted as 1, I really should, maybe somebody in the chat is telling me the answer to this already. Nobody in the chat has told me whether I should be counting from 0 or not when actually considering the depth. But so I might have off by 1 error, but I'm pretty close. It's going to let us answer the question. Now, what's the minimum depth? Well, if there are 2,000 leaves, we can think about it. How many, if there are 8, 8 divided by 2 is 4, divided by 2 is 2, divided by 2 is 1. How many minimum steps do we have to get to the answer? Well, 2,000 divided by 2 is 1,000, 500, 250, 125, et cetera, et cetera. You know, so I could keep doing this and count it, but there's another way to do this. Log base 2 of 2,000. That should give us the minimum depth. So we know that the tree could be organized anywhere between this minimum depth and this maximum depth. And so if we look at the answers, let's look at what log base 2 of 2,000 is. Google won't just tell me that. Log base 2 of 2,000 is 11, basically. So it should be anywhere between 11 and 1999, 2000. And you can see this is the correct answer. It can't be 10. It's got to be at least 11. But it could be 15, 150, or 1500. Let's see if I did that right. Yes. So it has to be greater than 11. And the number of leaves minus 1, 1999. So that's the way to consider the depth, anywhere between 11 and 1999. Thank you to Gordon Chan, who has answered this. And there's a nice discussion of that here. All right. So now, today's challenge, which this is from yesterday, I'm going to go back, is how long is the journey? I haven't answered this one on purpose. So now let's look at this. You have, and I'm going to let you think about this while I take a break and get some water and do some other things. You have 2 decision trees. Little tree has 41 nodes, 20 question nodes, and 21 leaves. 21 leaves. That's kind of the key number for you there. Big tree has 2,001 nodes, 1,001 leaves. You don't know anything about how either tree is organized, right? It could be a perfectly balanced decision tree, or it could be a sort of like the worst case scenario where there's a depth, a row essentially of that tree for every single question. So So you're going to ask each tree a question, and you don't know. In the case, by the way, of this tree, it could take you could get lucky, and you get the answer after just like one question. So, but you could also get unlucky in this case and have to go to, ask like 1,999 questions. If it were balanced, you would know that you always have to ask 11 questions. But so the minimum would actually be 1. The maximum would be 1999 if it's unbalanced. If it's balanced, it would be 11. So in this case, with these two trees, which of the following statements are true? Would little tree always be faster than big tree? Think about that. If you don't know how they're organized, isn't there a way that you could organize big tree and organize little tree so that big tree was actually sometimes faster? Not always, but sometimes faster? I don't know. Think about that. For some tree shapes, using little tree is sometimes slower and sometimes faster. And then for some tree shapes, using little tree is always slower. So this is, I think a way to think about this question is just to think about those two extreme cases. What if both trees are perfectly balanced? What if both trees are perfectly unbalanced? What would the answer for all three of these questions be? So think about that. I'll come back in about 5 minutes and do the answer. Write your response there. You can sign up for free at brilliant.org/coding train. Please go to that URL. Lets them know that you found Brilliant from the Coding Train, and that helps me out if you feel so inclined. And also, if you're interested in a premium subscription to get access to all of their courses and all of their materials, the first 200 subscribers to sign up from that link will get 20% off. Okay, so I'm gonna mute my microphone. Let me make sure this is oriented so you can see it. I'm gonna mute my microphone, and then we will come back and discuss the answer. I'll be back. Actually, I'm gonna take away my image and play some music. Hopefully I'll do that correctly this time. As always, I always forget the this dot, this dot, this dot, this dot. I'm going to do this dot, this dot. I'm going to do this dot, this dot, this dot. I'm going to do this dot, this dot. I'm going to do dot, this dot, this dot, this dot, this dot song. This dot, this dot, this dot. Never forget this dot, this dot, this dot, this dot, this dot song. This dot, this dot, this dot. Never forget this dot, this dot, this dot, this dot. I'm gonna do this dot, this dot. I'm gonna do this dot, this dot, this dot. I'm gonna do this dot, this dot. I'm gonna do dot, this dot, this dot, this dot. I'm gonna do this dot, this dot. I'm gonna do this dot, this dot, this dot. I'm gonna do this dot, this dot. I'm gonna do this dot, this dot, this dot, this dot song. This dot, this dot, this dot. Never forget this dot. This dot, this dot, this dot. Never forget this dot. I'm gonna do the this dot, this dot, this dot, this dot, the this dot song. Never forget the this dot. Somebody compose that song for me. And I'm gonna say once again, here we go. Sing it with me. It's the polar to Cartesian coordinate song. It's the polar to Cartesian coordinate song. Auto-tune and the internet will fix that for me. Sing it with me. It's the polar to Cartesian coordinate song. 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 I think my mic is back on. Boom, I am now visible. I am back. Okay, so let's talk about this problem and think about it. All right. Hopefully you've thought about this. Maybe you have an answer. Maybe you already submitted an answer on Brilliant. If you did, I hope you signed up through brilliant.org/codingtrain. But let's talk about the answer to this problem right now. You have two decision trees. Little tree has 41 nodes, so 21 leaves. Big tree has 2001 nodes, so 1001 leaves. We don't know anything about how either tree is organized. So if answering any single node's question takes the same amount of time, so it's like you don't have to think about the questions for a longer period of time wherever you are on that tree, which of the following statements are true? For some tree shapes, using little tree is always faster than using big tree. Let's think about that. So remember, I talked about previously, in the case of a balanced tree, a perfectly balanced tree, it takes log base 2 of the number of leaves, log base 2 of the number of leaves. So if we're thinking about log base 2 of, how many leaves were there again? 21 and 1001. Log base 2 of 21 is always going to be less than log base 2 of 1001. So this is true, I would say. All right, now, the second question. For some tree shapes, using little tree is sometimes slower and sometimes faster than using big tree. So let's think about that. This is relevant to the case of the worst case scenario, where every single level of the tree results in a leaf. So it's possible that sometimes you're just going to get, even in the tree with a depth of 2,000, that you're going to get to the answer off the first question. Whereas in a tree with a depth of 20, you could take 15 questions. So while on average, you would get to the answer more often faster, and that would be an interesting probability to compute, and we could run some simulations. So many things we could code with this. That it is possible that sometimes little tree will be faster. So that is correct. For some tree shapes, using little tree is always slower than using big tree. Could that be true? I'm just checking the chat to make sure no one's telling me. Okay. Could that be true? Could we come up with a shape where little tree is always faster? No. I don't think so. I don't think so. How could we prove that? I'm thinking about this. How could we prove that? Where little tree, well, we could come up with a shape where little tree is always faster. Is there a shape where little tree is always slower? No, because no matter what shape we pick, it's always going to have big tree is always going to have a maximum depth greater than the maximum depth of little tree, right? They could have each have a minimum depth of 1, or they could have different minimum depths, so that you could possibly sometimes little tree could be slower than big tree, but the maximum depth of big tree is always, no matter what the shape, is always going to be greater than the maximum depth of little tree. I think that's right. So I think this is false. Pretty sure I've gotten this right. So I'm going to hit submit. Correct. Phew. I'm not getting fired from my sponsorship job here. But getting it wrong is actually the point. Learning is trying to think this stuff, getting it wrong. And let's look at the explanations. So we can look at the explanations. Here we go. This looks like a nice one. So what happens is you can sort of react to the explanations, and some of them bubble up to the top. And I've been seeing Yoa, Pedro, Alfonso quite a bit bubble up to the top here. So if we look at the minimum depth and the maximum depth with a balanced trees, we have 4 and 5 and 9 and 10. And we have 1 and 20 and 1 and 1,000. So for some tree shapes, so starting with a balanced little tree at depths of 4 or 5, we can only increase depth of 1 or more leaves if we decrease the depth of the other leaves. If some increase to more than 4 or 5, others must decrease to less than that, so it is not possible to put everyone with a depth greater than the depth of the best big tree, the balanced big tree. So it's really, unlocking this is really about looking at the possible minimum depth and possible maximum depth. Let's see some other explanations. So I would love to see anybody watching, if you're so inclined, add your explanation there. I'm going to check this later. Let's make, if you make a P5 sort of sketch that animates this or explains this, please share that with me. All right, thank you again for this Brilliant. Please, if you're interested in more about Brilliant, go to brilliant.org/codingtrain to sign up and let them know that you found Brilliant from the Coding Train, and the first 200 subscribers, if you're interested in the premium service, we'll get 20% off. All right, so I think before I go, it's almost 1 o'clock, and I always say I'm only going to live stream for 2 hours. I seem to make it to 3. I think I would like to take this Rubik's Cube simulation that I just previously did and actually animate it. I'm feeling it's a little warm in here. I'm going to move my microphone to the shirt, and I don't think I'm going to wear this sweatshirt anymore. This animation requires, so let me move the code back to, so a couple things I want to do is let me do save as. This is going to be part 3. And then Let me, what do I want to do? Save that. I saved it as part 3. Oh, and I don't want it full screen. Let's just go back to, here. And you know what? Let me do something. I think it'll be a little nicer if I just like add those rotations. So let me just actually do some things. Turns. There's so much code here. Let me take these 3 functions and put them on a separate tab. And let me try like rotate x by like 0.2 and rotate y by 0.3 and maybe like rotate z by like negative. I just want it to start. Actually, so let me rotate y down so I can see it to top. Oh, that didn't work. Oh, because we do that first. Oh, no, that's rotate x that I want to do down. Ugh. Let me do that a little bit more. I'll just do these arbitrarily. I'm just trying to put it in some kind of, let me rotate y a bit more also. That's pretty good. Do it a little more. Rotate x, little things. There we go. I just wanted to start in a slightly rotated position so that when I do this, I can watch it go. Okay, so, oh, by the way, I shuffled my cube. So maybe I'll work on solving it. Maybe I'll work on solving it before I go. Do I still have my overhead camera? Whoops. Yes, but I'm not going to do that right now. Although this would be good for me to, I should be using this when I want to like talk about the cube, because if I look at it over here, it's not close up, but whatever. Okay. All right. Oh, wait a second. Are the sides wrong? Ugh. Yellow. Red. So I'm looking at it, yellow, red, green. Whoops. Yellow, red, green, orange, white. No, they're in the right orientation. I might have up, down, left, right messed up, but you know, whatever. It does all the parts. Okay, I want to do the animation. All right. So actually, let me erase my decision tree stuff in case I need to use the whiteboard. I'm going to be really glad when this Rubik's Cube project is over. There's all this other stuff I was like intending to do this month, and I'm like totally obsessed. All right. Okay. Welcome to part 3 of my Rubik's Cube coding challenge. What I have currently is a Rubik's Cube simulation where I can do all the moves, up, down, left, right, clockwise, counterclockwise, all that stuff. And I can make a random sequence of moves, then I can play out those moves, do them in reverse, and I can see the result of that. The Rubik's Cube is shuffling and unshuffling. However, I guess I have to, it won't do it again unless how come it won't? Hold on. I want to make it, I want to be able to hit the spacebar and have it do it again. So if I do the spacebar, key pressed, controls. What did we call it? Counter equals 0, yeah. All right. Okay. Welcome to part 3 of my Rubik's Cube coding challenge. But what I have so far, oh, wait. I want this to be here. I'm gonna get it. Ah. Well, I have to blow my nose. Hello and welcome to part 3 of my Rubik's Cube coding challenge. So I've done 2 parts already. If you watch those, I'm very thankful to you. But I'm going to do something really important in this. And it's really not about the Rubik's Cube at all. It's really about animation. And I want to be able to just do something to make it a little more visually pleasing to watch it do stuff. So what it does right now is if I hit the space bar, it's going to shuffle a whole bunch of moves, all the possible moves, up, down, left, right, clockwise, counterclockwise. It can do any move along any axis. It's also then going to it's doing a random sequence of 100 moves, and then it's going to do those in reverse. And you can see it looks kind of like it's solving it. Of course, it's not. It's just doing a random sequence and then applying it in reverse. Hit the space bar again, and it's going to go again. It's actually doing the same sequence again. So this would be, I think, more, I would be a little more confident that it's working correctly if I could actually watch the cubies rotate themselves to actually turn. So in order to do that, I need to add animation. I need to actually use the rotate function to do that. So I have to figure out how to do that. Add double turns. Yeah, that would make sense. Okay. All right. I think a way that's going to make sense to do this is to create a class called move. And each move is what? It's a given axis. Like what's the axis it's moving? What's the direction it's moving? And then if I'm going to do an animation, I need to animate an angle from 0 to 90 degrees. So I need an angle, which will start as 0. I need to have an axis. And maybe what I'll do is just do x, y, and z. So I know what axis it is. Is that what I want to do? I'm thinking about this. Yeah. Yeah. Angle, axis, and axis. Yeah. An angle and axis, and I'll have that axis just stored in variables x, y, and z. So the x will be 1 or -1 if it's right or left. The y will be 1 or -1 if it's up or down. And the z will be 1 or -1 if it's front or back. So that's kind of, I think, how I'll deal with this right now. So when I make a move, I have to give it an x, a y, and a z. And that's all I have to give it. Oh, and a direction. So I need to know whether I'm rotating clockwise or counterclockwise, or the angle is going up or the angle is going down. So this dot x equals x, this dot y equals y, this dot z equals z, this dot direction equals direction, and this is this. So ultimately, I've kind of done this already in the sense that I have these functions called turn z, turn y, turn x. And those actually move the cubes around and rotate their faces, but they do it instantaneously. So what I think I want to do is create an animation that happens, then I finish that animation, then I quickly move everything around, and it'll look as if it's happening seamlessly. So let's just say, for the sake of argument, I'm going to have one move m. I'll call it move. And move m, and forget about this, well, I'll leave the sequence thing in here for a second. Move is a new move which is going to rotate the z-axis, the front face. So that is 0, 0, 1 in a clockwise direction. That's a move. Then I want to say move.start. I think I'll have a function called start, And what does that do? It sets a variable. I'll have a variable called animating. And it sets animating equal to true. I don't know that I'm going to need this, but I feel like I might need a flag to know when I've started or stopped. So then I need an update function. And what update will do is I could use lerp to like interpolate from 0 to 90 degrees, or I could just increase the angle. So let's just increase the angle right now. I'm going to say angle plus equals direction times some amount like 0.1. So I'm going to increment the angle by 0.1. And if angle is greater than half pi, then angle should go back to being 0, actually. And then I'm going to say animating equals false. So let's just see if I can get this to happen. So basically, if I have a move, and then I say move.start, then in draw, I just want to say move.update. And if I run this, so the data of the move is happening. That angle is changing, but I need to actually rotate these. So the way that I could do that is right here, when I'm showing the cube, I could check and say if cube, well right here I could just say if cube.z equals move.z. Let's just do that, right? If cube.z equals move.z, then I want to rotate z by move.angle. And I'm going to want to have a push and a pop here, right? That should then move. Z cannot be resolved or is not a field. Move has a z. Oh, cube index I. If cube index I, right. If cube index I dot z. Here we go. Look at it. It's turning. It's kind of doing something. What's it doing? Why does it keep going? Okay. So update should only update the angle if it's animating. So once it reaches the end, it stops animating. So now we should see it turn. Oh, you know what? I think I'm having this weird issue with processing, which is that it takes a little while for processing to start. So what I'm actually going to do is I'm going to have move.start go into when I press the space bar, just so I can be sure it hasn't started yet. So I'm going to run this sketch. I'm going to hit the space bar. There we go. Look at that. It moves, but look at this. It moves, but the red stuff doesn't stay there, because all I'm doing is creating the animation of the moving. I'm not actually updating the data. But I need to update the data so I can do all the future moves. But I think there's an easy thing I can do here, which is I can say move.update if move.finished. Then what do I want to do? Turn z move.direction. Turn z, isn't that a function? Oh, turn z move.z move.direction. So I think there's got to be a way I can encapsulate this into one function. There's no finished. So I probably could just use the animating Boolean, right? Let's add another one. Finished is false. Finished is true. And then Boolean finished, return finished. So now what should happen is it should animate. Oh, that's weird. Why is it going back and forth? So move updates if move is, because it's doing this over and over again. So in ultimately, I want them, when the move is finished, I want to turn it once and then be done. So really what I should do is put this turn z into the move. Yes. So actually, I don't know if I need that Boolean variable at all. What I want is when it's done, I want to actually just say turn z, move according to this z and this direction, right? And then I don't need this finished stuff. I'm going to keep that in there just in case I need it. So now it should turn. There we go. Look at this. Oh, So now I'm turning it. So this is the idea. This is the logic. I just want to hit the space bar. It's doing every single move. Now the question is, now that I've got this working, how can I make every move work in the same way? So there's some things that are kind of hard-coded in here. For example, this shouldn't always be turn Z, right? This should sometimes be turn X, or turn Y, or turn Z. How do we want to deal with this? So before I do that, though, let me just make sure it works in other directions. So for example, if I were to say a -1, that should be the back of the cube. Okay, so that's working. And if I were to say 1, -1, that should be the front of the cube, but going now in counterclockwise direction. Ooh, okay. So that doesn't work. So why doesn't that work? Because if I'm going in counterclockwise direction, I'm going all the way to -½ pi. So that's something I need to fix. So here, if angle, so I could say if absolute value of the angle is greater than ½ pi. So if I'm going in the negative direction, I need to check -½ pi. That should fix that. Great. So now I can go in either direction, only in the z-axis. So what if I make a move that is now the x-axis? Oh, so if I say 1, 0, 0, 1, this should be right. I think I have things flipped, so it might end up being the left in the way that we're looking at it. But if I want to rotate along the x-axis, so if I do that now, it's confused. It's doing something totally nonsensical. That's not the correct rotation. So the issue here is that if cube z equals move z, right, because, so here what I really want to say, if absolute value of cube index I dot z is greater than 0, I probably should have a variable that's keeping track of the actual index. But really what I want to just say is cubes, is it the z-axis? Then do this. So now nothing should happen. Ooh, something did happen. Oh, because, whoa. Oh, it's still doing this. But I shouldn't see that animation. OK. So let's try to get the x-axis. Else, if the absolute value of cube x and cube x equals move x, then I should say rotate x move dot angle. Right, so this now would do the x-axis. And this should be an else if, because I'm never going to do two at the same time. So this should be rotating the x-axis. The issue is now in move update, when I get to this part, I don't want to do turn z, I want to do turn x. So that I could do the same thing, I guess, if by callback functions or something in JavaScript would really help me here. There's probably a way to do that in Java. But I'll just do the same thing. If absolute value of z is greater than 0, turn z. Otherwise, if absolute value of x is greater than 0, turn x, x direction. So this should be x. So I'm kind of getting lucky here because there's only 3 possible axes, but it definitely would be useful for me to use like an enumerable with like an index to the axis, but let's just see if this works. So now this should be the x-axis. Awesome. So that works. I've got the x-axis, so now I should be able to do the y-axis. Turn the y-axis. Axis. All right, now I should be able to do the y-axis, turn the y-axis. Let's just check a y move. Let's make the move 0, 1, 0. Oh, it's not animating. Why is it not animating? So what did I do wrong? Oh, I didn't do that here. I need to add the y. So now this should do the y-axis. Oh, no, something's wrong. Oh, I'm going the wrong direction. So I think this should be negative angle. Because my y-axis is flipped. Yeah, there we go. You know, I might have, whatever, it works. There might be something that I'm actually done wrong here, but I want the data is moving correctly. I just need to make sure the animation matches that. So now, instead of having this all moves be just these letters, now all moves is an array of move objects. Move, new move array with new move. So up is 0, 1, 0 in the one direction. You know what? Let's just do, I might as well just do them all. I mean, I can always invert them, but let's just actually do them all. So this is up in both directions. This is, okay, hold on. I'm gonna speed through this so you don't have to watch all this. Up in both directions, down in both directions. Right. Oh, shoot. Ah. Right. And left. And then I did up, down, right, left, front, back is what I need now. So front, front, back. So now, all right, I put in all the moves. Up, down, left, right, front, back, clockwise, counterclockwise. This should be everything. There should be 12 in there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's all the moves. So I should be able to now pick any given move and, all moves, and animate that one and just sort of see. This sequence stuff has to change. So the sequence stuff I'm going to do in a second, but I was using strings before. That won't work. Let me take this out. So any given move, I should be able to do. So this is move 3, index 3, 0, 1, 2, 3. So that should be the bottom. Oh, I've already spun it. That should be the bottom in a certain direction. Whatever. Great. So hopefully that's the right one that matches up. Now the sequence is, let's make it an array list. An array list of move objects. This will be the sequence. And I know if you're a cuber, there's actually like a back 2, but I'll just consider that back in the same direction twice for now. So we can consider this to be an array list of moves. And when I'm making that sequence, if I'm going to make, let's just do 10. I'm going to pick the size, and I'm going to say, pick an index. Then I'm going to have move m equals all moves get that index. And this has an extra, int random all moves size. Isn't that what's wrong with that? Errors. All moves is an array. Moves is an array list. So that's all moves index r. That stays the same. And then I'm going to say sequence.add m. So this is me putting in 10 moves in a sequence. So let's not worry about inverting the sequence. Let's not flip case, I think, is no longer a thing anymore. And then I need a current index is current move, which is counter. So I also need this to be, let's call this current move. So there's a current move, and current move starts at current moves equals sequence get counter. So it gets the first one. Then I'm going to say current move update. Guess what? This finished thing is going to come in handy. Perfect. If current move is finished, then index, what would I call counter, plus plus, and current move equals sequence dot get counter. And I definitely need to make sure that I only do this if counter is less than sequence dot length. So I'll put this if statement in here. I don't think, and I'm going to do this, whoops. Put this sequence in there, and then I'm going to say if started around here. So this is how sequence.size, not length. So this is the same exact algorithm, but instead of the move being indicated by a single character, it's now this object. So I'm updating that move when it's done, as long as I'm not at the end of the sequence, go to the next one and then get the next one. And then this current move is what determines the rotation. And so I called it just move before, but let's call it current move. And I think this should work now. Oh, move.start. Oh, okay, I'm not going to worry. Oh, this should be just started equals true. So now it's just a Boolean, but I'm not starting the, this could be current move start. This actually could be current move start. So because this can actually, current move update could happen if it's not animating. So yes, so I just want to start, hitting the spacebar starts the first move, which does all of these. And then each one, because I have this start function, needs to actually explicitly call start. Okay, this I think should work. So if I press the spacebar, we should see the moves happen in sequence. Oh! What? If counter is less than, it's got to be less than size minus 1, because this is where I increment. So I'm going to the next one. The last one is size minus 1. So that's good. So let's give it 50 random moves. And let's get it started. So now it's playing 50 random moves. It's a little silly that sometimes the moves are inverted. So now I should be able to add that sequence. What just happened there? What just happened? Oh! I'm not making a copy of the move. So a move is like animated and finished, and then when it gets it again, if it does that move again, it's not like a copy of the move. So this should actually be, when I make that sequence, yes, this should be like all moves.clone, or because there's a way to clone objects, but I'm just going to write my own copy function. So all moves index r.copy, or when I call start, I could set, I think it's actually as simple as just setting, you know what, I might be able to just not do a copy, but set the angle back to 0. Couldn't I do that? If animating equals true, finished equals false. Like that might actually work. So I could have made a copy of the move, but I think just in start, since I have to do that with everything, that might fix it. Let's see if that fixes it. A bunch of moves. It's going to do the same move again, just by the laws of probability. I think this is working, dare I say, and I can still spin around it. I mean, it doesn't look like it's making any mistakes. All right, so I want to make an animation speed now. I want to make an animation speed. Oh, and I should fix this faces thing, because you're seeing how there's like extra faces. I should kind of make the cubies at the beginning only include the actual faces that are on there. That's the thing that you can fix when you make your version of it. So now let's make a speed. Let's just make that a global variable. And right now it's 0.1, so let's make it like 0.5 to make it kind of faster. And then in move, this, I mean, I suppose that could be a property of the move itself. But let's just see it do it faster, because that's more fun to watch it do it faster. So let's see if now, if I add the moves in reverse, when it's done, it should be solved. It should be solved. Oh, and yes, this is a good idea. Fabian is suggesting use a move ID. So I could just use an index instead of a move object. There's so many different ways to do this. I'm excited to see how people refactor this and make it more interesting or better or different in all sorts of ways. Okay, now that I have all the moves, now all I need to do is go through the sequence backwards, right? Start with the last element of the sequence, go down to 0. Oh, this is where I kind of want to, I do need to make a copy because I need to make it a completely different move in the opposite direction. So I do want to say next move equals sequence get I, and I really actually need a copy here, so we'll see this both ways because then I want to say like next move dot reverse. So in the move object, or though I could just point to the other move, but I'm going to do it this way. I'm just figuring it out. I'm just having fun figuring this out. I'm going to make a function called copy, which returns a new move with what? X, Y, Z, and direction. And then I'm going to make a function called reverse, which just says direction times equals -1. So this, if I make those two functions, as I'm going through the sequence, I'm copying all of them but reversing them. And now I have, it should be twice as long. So let's just do this with just like 5 moves just to see if it works. Wait. Oh, wait. Where did I do that? Oh, I've got to add them. No wonder. I've got to add those moves. Womp womp. OK. Let's go. Here we go. So it should do those moves in reverse, and boom, there's the Rubik's Cube back in its original state. Now, here we go. Let's make it full screen. And enjoy this. Make it a little bit faster. Enjoy this Rubik's Cube doing 500 moves, then in reverse. This is going to take a long time. Let's not do 500. Let's just do 100. And you will get the feeling of the cube solving itself. You know, I really should do something where if I pick a certain move, I'm not allowed to pick the reverse of that move next, because that's going to make it look really weird. Like, why is it doing that? But that's neither here nor there. Here we go. Thanks for watching this coding challenge. Enjoy the end of this video. When I come back, if I do a part 4, which I intend to do, I'm going to try to work on some algorithms to actually solve the cube. So I should put a counter so I know what oh, the camera went off. Do this again. All right, hold on, everybody. Let me actually add something that I can see the text of where I am. I think I'll just console log it. So let's just do, just so I can see it, let's just do print line counter so I have a sense. And then I am going to print line counter. Oh no, but if I do it full screen, can I, hold on, let me take a break for a second here. Can I actually draw text? If I say fill, before I do any of this, if I say fill 255, text hello, 100, 100. Oh, that's fun. That's actually kind of fun. All right, that's fine. We'll just leave it like that. All right, let me actually draw the counter so I can see what move we're on, because that'll be somewhat useful. So I'm going to say fill 255, text, counter, I don't know. It's just going to end up being in 3D space in some weird location. Let's just say 100. Counter 100, 100. Oh, the scale is going to be weird. Let's just try that. Text size 32. And let's, there it is. OK, look, oh, look, it spins with it. So now we should see it's going through the moves. So when it gets to 100, it'll start doing the thing in reverse. All right, so I hope you enjoyed this coding challenge. I hope you make your own version of this. When I come back to do a part 4, if I ever come back to do a part 4, which I do hope that I will. There we go. Oh, look, cube solved. I will try. Oh, it won't do it again. Hold on. I had to reset the counter back to 0 for it to do it again. All right, let me put this. Let's have some fun with this. Let me put this on speed of 1.5. Let me make it do 1,000 moves. And here we go. And thank you for watching this coding challenge. Oh, well, it's not, you're not really seeing the rotation. It's just like shaking. OK, that's too fast. Let's try a speed just of like 1.0. All right, thanks for watching this coding challenge where I am shuffling the Rubik's Cube with random moves, then playing those moves back in reverse. It's gonna, when it gets to 2,000 moves, it will actually be back in its original orientation. I hope that works. I hope you make your own version of this. If I come back and make a part 4, which I intend to do, I'm going to see if I can use a genetic algorithm to take any shuffled state and evolve a solution within maybe a certain number of moves. I suppose 20 might be the number of to pick in terms of the genetic information, which will be a sequence of moves. This should be similar to what I did with searching for the phrase to be or not to be in the space of all possible random phrases. We'll see if that works. I have no other idea if that will work, but I'm going to come back and do more with this in part 4 in a future coding challenge. And please share with me. Go to thecodingtrain.com, look at the link in this video's description to, if you make a version of this, whether it's in JavaScript or processing or some other programming language or environment, you can submit a link to your version so that I can see it and the rest of the community can as well. All right, thanks very much. Goodbye. All right, I might as well let this finish. Whoa. I like how the counter is just spinning around. There's probably a way for me to do this and turn off PZCam, but it works. All right, I'm good for today. It's 1:30. We made a Rubik's Cube. Oh, I got to solve my cube. There's one algorithm that I don't really have memorized that I might have to look up. I'll put it on my hidden computer. Where am I? Let's see. Oh, I have an idea. We're going to make this like I'm racing the cube. This is going to be fun. All right, let's get rid of the counter. And, oh no, I think I want the counter there. So how long was that? Oh, I'm gonna need more time. I'm gonna race the cube. First, let me just show you that this is shuffled, right? So this is shuffled. I don't know what sequence this is in. I'm not keeping track of this in my head. You know me, I can't possibly do that. First of all, it's embarrassing. Relative to all you cubers out there who really know how to do this, my ability to do this is quite embarrassing. Okay, so now what am I doing? What do we think? What's the over-under on me being able to solve it whatever that takes to 10,000? Oh, let's actually leave it at 1,000. No, let's do it slower. Let's leave it at 100, but make the sequence much, like let's leave it at 100, but do it at, what was it, at 1.0? At like 5% of that. Okay, ready? Oh, wait, no, I need to put it back to not full screen, I guess. This is going to be fun. I'll play some music. Okay, ready? Oh, I should have it do the first part to shuffle it. So what I really should do is just apply all the moves. I should start it shuffled. I'm too lazy. I'm just going to do it this way. Okay, ready? Here we go. I'm so nervous. Oh! Go there. Thank you. Red, where are you, Red? Where's the yellow side? Oh, did I mess up the yellow side again? Come on. Where are you, Red? There you are. No, that's not red with white. Where's the piece with white? There it is, green. Oh, green. It's in the right place. Where's the yellow side? I can't find the other. This makes me so nervous. Oh, there we go. Oh, that goes here. Green, green. Oh, this is in the wrong place. Everything's wrong. I do know how to do this. I get so nervous. Red. There we go. Set myself up for success. What am I doing? I forgot. Solving a Rubik's Cube. Did I give it? Oh, there's no way I'm making it. Oh, there's no way I'm making it. It's yellow. Come on. Let me get lucky at least with my configuration. So I'm like shaking. I'm so nervous. Oh, there's no way. There's no way. Okay, that's good. That's good. No! Oh shoot! I screwed it up! Pause the processing check! I screwed it up! Ah! Shoot! How am I going to get it back? I messed up my sequence. Okay, I'm back. I'm back. Everything's okay, everybody. How's this one go? How's this one go? Okay. This is where I need to look this up. I'm looking over here. Oh shoot, I'm so close! Darn! Oh, that would have been much more exciting if I had gotten it. But I really only have one move away. What am I doing? Clockwise? Wasn't that far off. Oh wait, I already messed it up again. Shoot. Messed it up. Bad. But, you know, what are you going to do? If I just given myself a little bit more time, I would have gotten it. So that was way faster. How long was that total? Because that song, I did that in under 5 minutes. But I was looking up, there's just two algorithms that I was looking up that I don't have memorized for this way of doing it. All right. So I'm going to go I'm going to check the chat here. Oh, a lot of people are pushing for the inside faces to be black. The computer cheated. Oh, these are comments from a little while ago that I missed. All right, thank you, everybody. What method did I use? I don't know. I used some method of a combination of a bunch of different videos that I watched. I can turn off my overhead camera. Nope, that's here. I'm going to, so this code will be online very shortly if you want to use it for anything. And yeah, so maybe I can take a couple questions before I go. It's 1:35. It's been a 3-hour live stream. I feel accomplished. Apparently that was approximately 4 minutes, which, and I was doing that, at the beginning I had a lot of trouble there because I was so nervous. So that's pretty good. I would like to see if I would like to learn CFOP. Everyone's telling me CFOP, beginner CFOP. Is that what I was using? Okay. Like what I was doing, the parts that I know and are memorized. What I know how to do is I know how to make the white cross on the yellow side, move it to the white side, do the white corners, then do the middle row. That I can do. Then I also know then the thing I know how to do is to make the yellow cross on the yellow side. And then I hope that I get lucky, and I think I try the soon algorithm a bunch of times till I get that fish thing. And then I point the fish this way, and then I do that some more, and eventually I get the top. And then I had to look up some other algorithms for moving the center and corner pieces around. But where I basically stuck is at I can get the yellow cross from memory, not in the correct position every single time. So but I've tried a few different things after that, and I have them all mixed up in my head. So you learn F2L, which is part of CFOP for the first 2 layers. If you know that, you will be a lot faster. I prefer something that is like less memorizing algorithms and more actually able to kind of, because like the thing that I like doing the most is the middle layer. Like that, I do it by sight. But I'm not doing it by memory, but it's like a quick algorithm that I have to do so many. Jace in the chat, I don't know if I'm pronouncing your name correctly, Jace, asks, what algorithms are you considering for solving the cube in episode 4? So first of all, I don't know that any of these algorithms that I'm going to attempt are really going to do a good job. The first thing that I'm going to do is try to use a genetic algorithm. Like, is it true, I think there's like God's number, or that the cube from any configuration can be solved within 20 moves? Is that true? I don't know if that's true. Somebody told me that. I either saw it in a YouTube video, read an article. I need to research that. So what is the minimum? Because I can create a genetic DNA string for a sequence of moves, but it needs to be a fixed number. It's okay if it solves it in less than that, but it needs to be a fixed number. And then what I can do is I can create a population of those move sequences, run through them, and then I need some fitness function. The fitness function I'm going to need is to evaluate basically how close I am to the solution. It would be lovely if just counting the number of pieces in the right space would be a good enough fitness function. That's what I'll try first. I think that's going to be problematic. And I did read a paper about machine learning to solve a Rubik's Cube, and the methodology was basically the reward system or the fitness function had to do with distance from the solution. So you kind of needed to know how to solve it from where you were in order to figure that out. But I would like to try to do it without that, because I would like to see if I can solve it without sort of pre-knowing a way to solve it, but we'll see. There's no known algorithm for getting those moves from an arbitrary configuration. Well, I don't think it's going to be me who's going to figure that out, but this is what I'm going to try. 20 and a half turn metric, 26 in quarter turn metric. 20 turns with 180 turns, I think 24 with only 90. Okay. So I'm not going to learn a strategy for any random configuration. What I want to do is solve for the sequence of a particular configuration. If I can do that, that's at least a first step. Maybe 50. It took until 2010 that God's number existed. So people in the chat are telling me it has to do with whether I'm allowing for 90-degree moves or just quarter moves. I suppose, I'm sorry, whether I'm allowing for full 180s or just 90 degrees. All right. What is the sense of P5JS and P3? What do their names mean? Agorio part 3, please. I'm sorry, that's very nice of you to ask. And then I'm also being asked, what's the plan after the Rubik's Cube series? So the reason why I went down this road is I am working on, the thing that I'm interested in pursuing is more machine learning examples with ML5 and TensorFlow.js. And I wanted to try some more neuroevolution examples and maybe more genetic algorithm examples. And I sort of thought the Rubik's Cube would be like a nice thing to try with. It became a much more complicated project and I became kind of obsessed with it. But I think what I should be doing today, because it's what I taught in class this week at NYU, is I did neuroevolution with Flappy Bird, but using TensorFlow.js instead of my own toy neural network library. So that's probably what I would come to soon. I'm also working, it's happening offline, not during the live streams, but I'm working on a bunch of videos about data and APIs. It's a little bit of some redundant content of things I've done before, but updated. And so those videos will actually come out just as like edited videos in May and June. So is this the hardest, longest challenge you've done on your channel? Maybe. Maybe. What's been some of the other ones? I mean, there's a bunch that are of like 5, 6 parts, but whether they were harder or just took longer. You should watch my Pong challenge and see how much trouble I had with Pong. Okay. That fitness function would make it exploit way more than explore. That's kind of true. That's a good point. And there's a fine line. So I got to do some thinking and some experiments. Can you use can begin HUD and can end HUD? Oh, that exists? Oh, I didn't know you could do that. Thank you. Hold on. Where do I be doing the text? Let me add that. Can begin HUD, can end HUD. Oh, there we go. That's definitely, I wish I had known about that. I would have done so much debugging on the screen with that. Thank you. Not pawn, Pong, P-O-N-G. Thank you everybody for tuning in. This is a delight for me to get to do every week. I will be back. I am keeping this regular time every Wednesday at 10:30 a.m. Next week is April 17th. I think I'm going to miss April 24th if you're just sort of keeping track of your calendar. That's not 100% yet, but there's that. I have a conflict that week. So, and I'm certainly going to probably miss a date or two in May. So I'm going to try to do once a week every Wednesday. And I've got a ton of stuff to do and get to. And thanks for your continued support, your questions, your comments, your feedback. I really appreciate it. I am going to put on my wallpaper and turn the stream off. So this is random, this is noise, Perlin noise that is. In the core random algorithm, the actual random algorithm itself, those numbers aren't related at all. You pick, like, I'm picking random numbers between 0 and 10. 9, 2, 7, 3, 6, 5, 1, 9, 19, 4, 5, 8, 1, 9, 2, 1, 3. I pick 9 a lot apparently. But with Perlin noise, I might pick numbers like this. 2, 3, 4, 3, 4, 5, 6, 5, 4, 5, 6, 7, 5. Pear asked, what's next week? I don't know yet. I mean, in theory, I might just continue the Rubik's Cube. It'd probably be a good idea for me to take a break from it, but we'll see. I don't know what next week is yet, but stay tuned. I try to put it in the title when I schedule a live stream or tweet it out or that kind of thing. 5, 6, 7, 5, 6, 7, 8, really 9, 8, 7, 6. I mean, well, this is like Perlin noise performance art. 9, 2, 7, 6, 1, 9. 4, 8, 9, 2, 1, 3. I think 9 1. 2, 3, 4, 3, 4, 5, 6, 5, 4. Oh, this is like Perlin Noise performance art. 7, 5, 9, 2, 7, 6, 1, 9, 4, 8. But with Perlin Noise, I might pick numbers like this. 2, 3, 4, 3, 4, 5, 6, 5, 4, 5, 6, 7, 5, 6, 7, 5. Perlin Noise, that is. Perlin Noise. So this is Perlin Noise, that is. Perlin Noise. This is Perlin Noise, that is. Perlin Noise. So this is Perlin Noise, that is. Perlin Noise. Perlin Noise, that is. Perlin Noise. So this is Perlin Noise, that is. Perlin Noise. This is Perlin Noise, that is. Perlin Noise. So this is Perlin Noise, that is. Perlin Noise. Perlin Noise, that is. Perlin Noise. So this is Perlin Noise, that is. Perlin Noise. This is Perlin Noise, that is. Perlin Noise. So this is Perlin Noise, that is. Perlin Noise. Perlin Noise, that is. Perlin Noise. This is Perlin Noise, that is. Perlin Noise. This is Perlin Noise, that is. Perlin Noise. So this is Perlin Noise, that is. Perlin Noise. Apparently. But with Perlin Noise, I might pick numbers like this. 2, 3, 4, 3, 4, 5, 6, 5, 4, 5, 6, 7, 5, 6, 7, 5, 2, 3, 4, 3, 4, 5, 6, 5, 4, 5, 6, 7, 5, 6, 7, 5. Well, this is like Perlin Noise performance art.
I will refactor this later, you know.